Alrighty guys, welcome back to your remote learning experience. Oh crap, I did not mean to do that. Off to a good start. So this lesson is going to be for, hang on a sec, bear with me. This is what I wanted. Here we go. So this lesson is going to be for Monday, April 6th, okay? So we are still out of school, I'm sure you guys know. The decision will be made May 4th whether or not we go back to school, but I do want you guys to be prepared for if we do not go back to school for the rest of the year, okay? Just keep that in the back of your mind. I'm not trying to be negative in any way, but it is a possibility, so keep that in your back pocket. Hope you guys had a great weekend. Hope you got some good rest. Maybe got to get outside a little bit. I know it was beautiful today, so I got outside a little bit and took a walk, did some fun things. So one thing I do want to announce is my office hours have changed. Originally, this was on Tuesdays from 1 to 2 p.m., but now it is on Thursdays from 1 to 2 p.m. because now, starting this week, we have flex days on Tuesdays. So those flex days are going to be a day for you guys to kind of catch up, help teachers collaborate with one another through different meetings and such. And so, yeah, those are going to be flex days. I'm going to send out a whole email to you guys about changes that have been happening in regards to the flex days, to the end of the quarter being changed, and also in relation to the competencies. So I will answer as many questions as I can through that email, but if you have additional questions, please just feel free to email me, okay? So it's going to be a few changes going forward, but I think we can handle it, all right? So due to the quarter change, we're officially in quarter 4 now. So this is the very beginning of our quarter. We only have really like 3 or 4 assignments in right now. So now is a time more than ever to stay on top of things and just really get it done for this quarter. Okay, this is going to be the last quarter of our school year. So now is the time to just finish strong and stay on top of whatever work you have. And if you're having trouble, you can always lean on me. Please ask me for help, ask me questions. If I need to set up a Zoom call with you, I will absolutely do that, okay? More information on all that stuff I mentioned to come. But now we are going to get into mole conversions. Excuse me. So this has been happening, or this has been happening. This is something that I've been telling you guys about, something I'm super excited for. I can see a look on your faces right now. I just know you guys are super excited for mole conversions. But this is going to be the time where all that dimensional analysis practice is going to come into hand. So when we did conversions from grams to liters to milliliters to centigrams to whatever unit you can think of, okay? Because now we are going to be converting between different units like moles and grams and particles and back to grams and back to moles and back to particles, things like that, okay? So this is going to be super helpful for you going forward in just looking at the conversion factors that we've talked about, okay? But first, before we get into those conversion factors, I want to talk about a few equalities that we've kind of gone over non-directly so far, okay? So this week is going to be super helpful for us understanding that in chemistry, sometimes we only get to work with a certain amount of materials. And so this is a way that we can kind of convert and figure out in a chemical reaction how much of a substance we would need for the reaction to happen with nothing left over, things like that. And this will make much more sense once we get to the actual mole conversions. But today we're just going to talk about those conversion factors, okay? And if you guys, or I'll go over the conversion factors in just a sec. But I'm going to do some drawing here, so I'm going to be prepared for that. So just some equalities that we've gone over so far. We've learned that 1 mole is equal to the formula mass of a substance in grams, okay? So you can find that directly on the periodic table, and that could be anything from like, if you look at the periodic table and, hang on, this is my Google search from earlier. My pen was not working, and I was very sad. Here we go. So the formula mass being, hey, oxygen, if you look right below oxygen, it's 15.999, all right? That's the formula mass, okay? And that is measured in grams, okay? All right. Then we have 1 mole is also equal to 6.022 times 10 to the 23rd particles. In this case, that could also mean atoms, all right? Next, we have 1 mole of a whole compound is equal to moles of individual atoms, okay? So, if I had some carbon dioxide, which I'm sure you guys are all very familiar with, okay? That would be equal, so 1 mole of carbon dioxide would be equal to 1 mole of carbon atoms and 2 moles of oxygen atoms, okay? So that those could also be considered equal to each other. Why does that is so weird that it gets big like that. All right. Last but not least, something we have not yet learned is that 1 mole of a gas occupies 22.4 liters at standard temperature and pressure, or STP, okay? So standard temperature and pressure is just kind of it's literally a standard. And whenever you say STP to someone, all that means is that the conditions in the surrounding environment are at 0 degrees Celsius and 1 atmosphere of pressure, okay? Which is it's not super important, but that's just what the conversion would be. That 1 mole of a gas occupies 22.4 liters of space. Okay, so hopefully this will make a little bit more sense once we get into some practice problems. But if it doesn't, please feel free to email me and I will absolutely answer any questions that you have. Moving on. So we need these equalities because we need to create conversion factors for dimensional analysis problems. Okay, so if you guys remember, let me see if I can go on a whiteboard. Whiteboard, yes. If you guys haven't used Whiteboard on your Microsoft apps, you sure are missing out. So if you guys remember, I would kind of write this down in your notes somewhere, that with a conversion factor, okay, our conversion factor is going to be whatever we're converting to is going to be on the top, and whatever we're converting from is going to be on the bottom. So for example, if I wanted to go from 1,000 grams to kilograms, all right, I would start with grams, okay, grams, and I would multiply that by my conversion factor. And my conversion factor would be whatever I'm converting to, and I'm converting to kilograms, so kilograms would be on the top, and I'm converting from grams, grams would be on the bottom, and you would need some sort of conversion factor sheet, but for this case, 1,000 grams is equal to 1 kilogram, so I would just put that conversion factor in here and say 1 kilogram is 1,000 grams. I would do that out. I would do 1,000 times 1 divided by 1,000, which just happens to be 1 kilogram, right? But this is the most important part to remember, is that conversion factor. Converting to is on the top, converting from is on the bottom, okay? So if there's one thing I want you to get out of this, it's that guy right there. My computer sounds angry at me. It's making lots of noise. Okay? So, for example, in this very first one, these are conversion factors that you guys are going to be using, so I would write this down somewhere. So for example, if we wanted to go from moles to grams, okay, our conversion factor would either be 1 mole over whatever we have in grams, or whatever we have in grams over 1 mole. Okay, this will make much more sense once I get into an example, so don't be nervous about this, all right? And all that or means is that it depends on what you're converting to and what you're converting from. So you could use either of these depending on the situations, okay? Also, if we have mole and particles, this could be our conversion factor. So 1 mole being 6.022 times 10 to the 23rd particles, or 6.022 times 10 to the 23rd particles over 1 mole, okay? So think of these conversion factors that I'm giving you right here as kind of the one that I just did in this example, all right? And it's just that kind of 1 kilogram over 1,000 grams. Okay, so just think of it kind of like that, all right? It's just an example of a conversion factor that we might try to use to solve a problem, okay? All right, lastly, 1 mole equals the moles of the atoms, okay? So for example, if we had 1 mole of CO2, it would be equal to whatever moles we have in atoms, which is what I did on the previous page. So 1 mole of carbon dioxide over 2 mole of oxygen atoms, or it could be 2 mole of oxygen atoms over 1 mole of carbon dioxide. Okay, I want to get into the examples because I think this can be very confusing, but we will get there. Okay, so first I want to do an example with sodium sulfate. Okay, and we're going to try to see how many of these equalities right here, or rather right here, that we can find in this compound sodium sulfate. Okay, so to start, we have 1 mole of sodium sulfate is going to be equal to the mass in grams, okay? And that just happens to be 142.04 grams is equal to 1 mole of sodium sulfate, okay? And we can find that by just looking at the periodic table, okay? Because right now I have 2 atoms of sodium, all right? And 2 atoms of sodium, each of those is going to be around 23 grams times 2. So that would be, what is that, like 46 grams? And then I would have 1 atom of this sulfur right here, which is 32.06. And then I have 4 oxygen, which is equal to 64 grams, because each oxygen is going to have a mass of around 16 grams. Okay? I think that's correct. Correct math. Yeah, we're good. Okay? So if you add those all together, it would equal around 142.04 grams of sodium sulfate is equal to 1 mole of sodium sulfate. Okay? So, for example, if I gave you a problem and I said, hey, how many grams are in 2 moles of sodium sulfate? You would say, hey, Mr. Shane, I know that because I know that 1 mole of sodium sulfate is equal to 142.04 grams of sodium sulfate. And you would just take out your little pen and paper and do a little math. Say, all right, Mr. Shane, so if you have 2 moles, that means whatever you're converting to goes on the top, all right? So you want to know how many grams you're getting. Grams goes on the top. You're converting from moles, so moles goes on the bottom. And 1 mole of sodium sulfate is equal to 142.04 grams. That means you're going to have whatever 2 times 142.04 is how many moles you would have, or how many grams you would have in 2 moles of sodium sulfate. I'd be like, wow, you're really smart. Maybe you should teach this class instead of me. You should be like, all right, Mrs. Shane, I'll do it. I'll be like, all right, please do. So hopefully that makes a little bit more sense into kind of what we're doing. But there are a lot more equalities in this compound that we could use to kind of figure out different problems. So for example, 1 mole of sodium sulfate has 6.022 times 10 to the 23rd molecules of sodium sulfate, all right? Also, in 1 mole of sodium sulfate, we have 2 moles, 2 moles of that sodium ion, all right? And that sodium ion has a charge of +1. Also, if we have 1 mole of sodium sulfate, we have 1 mole of the sulfate ion, SO42 minus. We could also have just 1 mole of sulfur atoms and 4 moles of oxygen atoms, okay? So there's a lot of different equalities that you can find in this that would help you solve another dimensional analysis problem. I'm really concerned why my mouse gets so big when I shake it like that. If you know how that works, let me know, because I'm confused. All right, let's do one more, and then I'm going to give you guys a practice sheet, and hopefully you can do things like this, all right? And if you have questions, just let me know, all right? So if we have carbon dioxide, and it's in its gaseous state, like this, right? And we're going to have this gas at standard temperature and pressure. So that's going to be 0 degrees Celsius, 1 atmosphere. These values aren't super important, but they do exist, all right? So 1 mole of carbon dioxide gas is equal to 44.01 grams of carbon dioxide. Because if we look at the periodic table, we have 12.01 grams of carbon just looking at this number right here, or 12.011, but I'm going to round, all right? And then we have these 2 oxygen atoms, which adds up to 32 grams of oxygen, and that would equal around 44.01 grams of carbon dioxide, okay? We've already done this. This was like the formula mass and molar mass stuff that we did a couple weeks ago, all right? 1 mole of carbon dioxide is also equal to 6.022. There's not another 2 right here, but let's just pretend it's there. Times 10 to the 23rd molecules of carbon dioxide. 1 mole of carbon dioxide is equal to 1 mole. There's 1 mole of carbon in there. There's 2 moles of oxygen in there. And lastly, this equality, which is, since we have a gas, 1 mole of carbon dioxide is equal to 22.4 liters of carbon dioxide, all right? Which we discovered in this slide right here. Because 1 mole of a gas is equal to 22.4 liters, okay? Since we have a gas, we can assume that there's 22.4 liters of carbon dioxide in here, okay? So just as a little application, oh goodness, help, my computer is embarrassing me. Over here. All right. New whiteboard. It's like I'm standing at the board at the front of the classroom, and some of you are on your phones, not paying attention to old Mr. Shane, you're looking at TikTok, and some of you are looking at me like I have 4 heads. But it's fine. All right, so for example, if I said, hey, you, student of mine, how many molecules of carbon dioxide are in 2 moles? All right, and you would say to me, hey, Mrs. Shane, 1 mole of carbon dioxide, whoops, oh crap, is equal to 6.022 times 10 to the 23rd molecules. You're like, remember that, Mrs. Shane? I'm like, oh, duh, thanks for reminding me. And you're like, well, Mrs. Shane, if you want to know how many molecules are in 2 moles of carbon dioxide, all you'd have to do is set up your conversion factor. And I'd be like, well, how do you do that? And you'd be like, oh, let me show you, Mr. Shane. Come on. You'd be like, Mr. Shane, remember? Whatever you're converting to goes on the top, so you want to know how many molecules you're going to get. I'm like, all right, got it. And whatever you're converting from goes on the bottom, and you're converting from moles to Mr. Shane, and I'm like, you're so smart. All right, erase. All right, and you're like, well, Mrs. Shane, all you got to do is plug and chug that conversion factor, 6.022 times 10 to the 23rd on top, 1 mole on the bottom. And I'd be like, whoa, you're so smart. All right, then whatever this is, 2 times 6.022 times 10 to the 23rd. Oh God, what is that? I'm going to need an extra calculator to help me. 6.022 times. Oh crap, how do you do this? Help. Where's the thing? All right, it would be whatever, the answer would be whatever 6.022 times 10 to the 23rd times 2 is, okay? That's all we really need these equalities for, is just to set up conversion factors, okay? So you are going to have some worksheet, or a worksheet coming up. We're going to need to find as many equalities as you can, okay? So you're going to need to find these on your own, okay? And I absolutely can help you with that. But try to use whatever tips I gave you from this video. And if you're like, Mr. Shane, you were kind of just rambling the whole time, not making any sense, shoot me an email and I will gladly explain it to you again. Okay? So that's going to be it for today's video. Hope you guys have a fantastic rest of your Monday. Remember, tomorrow is Flex Day. No new assignment going out. No new content going out. It's just you and whatever you got to do for yourself. Okay? Have a great rest of your Monday and talk to you guys very soon.